to settle your brain, to make sure you got the handout. And if you've seen this before, try not to be too bored as I teach it and show you the one little hiccup that you got to watch out for in these things. This lesson's called the Pythagorean Theorem. This chapter's called Trigonometry. But I'll give that away right now. I'll tell you why it's called trigonometry. Triangles, yeah. We're going to be talking about triangles a lot in this chapter, like we were last chapter. You might think the last chapter is trigonometry, and it actually is, but now it's a little more formalized. Don't be scared. Don't be scared of this stuff. You just need a few words at your disposal. My job to give you the words. So today the learning goal is to find the missing side length in a right-angled triangle. That's all we'll be able to do, is ones that are right-angled. And then we'll know we're successful if we can find the hypotenuse or use the Pythagorean theorem to find something that's not the hypotenuse. I don't remember what a hypotenuse is. Okay, that's what we're going to do right here. You ready? Shh. Shh. The Pythagorean theorem, the triangle to the right is a right-angled triangle. The music's still playing. There we go. Because it has a, well, I could write right in there, but I'm not going to. I'm going to try and be more helpful than that. Because it has a 90-degree angle. And we indicate 90 degrees by this symbol here. Do you remember this symbol here, this little square in the corner? All that square means is this is actually 90 degrees. If that square is not there, you can't assume something is a 90-degree triangle. It's got to be there to know that it's a 90-degree triangle. The longest side of the triangle, C, is opposite to the 90. And what I mean by opposite is, watch this. I'm going to use a little arrow and say, look it. That one across the triangle from the 90 is called the hypotenuse. Hypotenuse. Strange name. Hypotenuse. I'm going to put it on your diagram too. Some people are more visual. They don't want it in a sentence. They want the picture here. So this one over here, little squiggly arrow here, hypotenuse. Does that name sort of ring a bell way back when? Grade 9, grade 8, maybe? Hypotenuse? Maybe? Yeah. Not hypothesis. I know you do that in science. Hypothesis. It's unfortunate those two names are so similar, but this is hypotenuse. The other two sides, A and B, are called legs. We won't always use that word, though. Sometimes we'll just call them the other two sides. But they're called legs. So here's the Pythagorean theorem. Here's what the Pythagorean states. And it's an ancient theorem. This goes back to before year 0, BC. Before Christ. Like, this is a long, long time ago that they came out with this. He's on the wall here, Pythagoras. Let's read what the sign says. The oldest, shortest words, yes and no, are those which require the most thought. Oh, that's a quote from Pythagoras. I thought we were going to get a little biography of him. Way, way, way old this theorem is. And they proved it. They proved that this was true about right-angled triangles. I'm going to do it in words first, and then in letters. Most people like it in letters better. Okay? Here it comes in words. The square. Of the hypotenuse. Equals the sum of the squares. I'm already starting to laugh at this. Of the other two sides. Often that will say the other two legs. But I'll use sides. I think that's a little easier for us to say sides instead of legs. That's not how most people want to see it. For once, you're going to like algebra better here, because the algebra is much easier to look at. Does anyone remember what this looks like algebraically? I'll start you off. C squared equals a squared plus b squared. Pretty easy looking, actually, and it can be. As long as you know how to square a number and you know how to add or subtract, you should be good here. Shouldn't be too bad here. Fairly popular stuff, actually, with grade 10 students. I don't mean that like I'm trying to do a sales pitch for it. I know sometimes I try to convince you to like something for your own good, but in the years I've taught grade 10, a lot of people like this stuff. It's like, okay, this I like. I didn't like that other math, but I like this stuff.
Is this our last unit?
No.
How much more do we got?
We have this unit on trigonometry that we will try to finish the best we can before Christmas. And then we got one unit on measurement coming back. So that would be like perimeter, area, that kind of stuff. Volume, you know, and that stuff too is also stuff that grade 10s often like. So I won't say the worst is over, but a lot more popular stuff coming up for grade 10s. Yeah. Do you have any questions there? Do you need more time? Okay, here come the examples. Example 1. The only question in these is, am I going after the hypotenuse? Which side is the hypotenuse? Yeah, if you're having trouble with this, that's the way to do it. It's just to write an arrow across from the right angle like that and just go, okay, and label that hypotenuse. If that's difficult for you at all, put that arrow on there. There is another way to know what the hypotenuse is, and some people like this better. The hypotenuse is, it's away from the 90. That's true, and that's what my arrow shows. But there's something else true about the hypotenuse. How is the hypotenuse different than the other two sides? It's the longest one. That's key. It's got to be the longest side. So I don't know. You could write down the Pythagorean theorem. You don't have to. You don't have to write down the Pythagorean theorem. You could just write what it means in this question. So I'll do both. Okay? So I'll do in blue. I'll do what you could do. You could just jump right in and go x squared equals 6 squared plus 8 squared. And there's work to be done. There is work to be done. But you're mostly home once you write that down. Some people like to write the theorem above it. I'm not against that. And maybe there'll be times when I would say you have to write it. But I'm not going to teach it that way. I'm not going to teach that you have to write this every time. I'm going to teach that you can just look at the triangle and go hypotenuse squared. I'm going to put on the left equals the sum of the other two squares. So now we got two things you could do. If you've got a calculator with a squared button, you could just hit 6 squared. Yeah. If not, what you've got to do is 6 times 6. And this is 8 times 8. And I'm certainly not suggesting you should do that in your head because this one are reasonably friendly numbers, but we're going to do Pythagorean theorem with not friendly numbers, so you're probably reaching for a calculator. What is 6 times 6? 36. Again, type it in your calculator. Either way, 6 times 6 or 6 and hit the squared button. I think you'll find the calculators in the room here have a nice squared button. You just hit 6 squared, boom, answer. And then 8 squared, 64. So then I got to add those together. 36 and 64, 100. Now a long pause. The only difficult algebraic step is what to do now. We know x squared is 100. What number do you square and get 100? 10 is the number, right? Or there is a button in the calculator that does this for you. It unsquares. It'd be nice if that's what it was called. But it actually is a square root button. It says, find out the side of the square. We know we've got a square that's 100. We want the square root. 10. So I'll write the extra step. You just find the square root of 100, and you write 10. And then somebody goes, wait a minute. So the little check mark deal thing over the 100, that finds the answer for me of what was squared. And I'm like, yes, that's exactly what that was invented for. Somebody made the calculator able to calculate what got squared to make 100. Thank you. I'll put that there. And then I'll give you this here. That's what we've been working on. Very good. It's almost right. The number's exactly right. But what else should I put in my answer here? 10 camels, 10 wagon wheels, 10 lizards. Centimeters. We really, really should put the units in the answer. In fact, we really should make a therefore statement. But I'm not going to hold you to that right now. We can do these like this. We'll worry about the therefore statements when the word problems come up, okay? Any questions? Does this ring a bell? It's like, yeah, I sort of remember this. Yeah, okay. Do you need more time? We'll try another one. She says, let us try it and see if we can do it. That's confidence for you. Grab a calculator, take a minute, and try this out. See if you can do it. Write whatever steps you need to. How much time do we need? I'll set my timer. Set a 2-minute timer. Let's see what you can accomplish in 2 minutes. Yeah, I will. Can I do it in my head? Yeah, I can do it in my head. Yeah, friendly numbers, right? I'm using friendly numbers so far. And if you can keep going, wow, okay. Don't do C unless you know exactly what you're doing. Because C is the one curveball in the whole thing. I know math always seems to have a curveball. C has the one curveball in the whole lesson. Oh yeah, but we'll talk about that tomorrow. You don't have to worry about that at all until tomorrow, okay? Yeah, that's tomorrow's. You're just a step ahead of us. That's good. Just focus on Pythagorean theorem. We need to be good at that first. Anybody need a calculator over here? I'm glad to hand deliver calculators to anybody. Well, you can't have it. Ha ha, you're so funny. Maybe we should use this thing as you go up and get a calculator, then you put your phone in the slot, and then you come back to your desk to be productive.
I have mine. This is Katie.
Oh, Kate, nice tone here.
Thank you.
Much more. Wow. Wow.
You would die of my friend.
If you need a hint, don't look up unless you need a hint. If you've got it under control, just do yours. But I'll start the first line up here, okay? Ooh. I'll move slowly. You can look up while you're doing it. Don't look up unless you feel confident. Then you can look at mine and see if you got the same thing as me. Our 2-minute timer's up, but that's okay. Keep working. You're right. C, we're going to have to think again. So we'll do Katie's suggestion. We'll do C together. Yeah, something's up. Something's up. Okay, just hang on. Something's up. I'm going to show you. I'll give you 2 options. 2 ways to go with it.
I was looking at a different question.
Oh, that's right. How'd you do?
20. I got it right.
20.
Yeah.
Camels?
Yeah.
Wagon wheels?
Nah.
Centimeters, please. We've got to get good at this. We've got to get good.
I was looking at the M.
Yeah, I know it looks like meters, doesn't it? But it was M, but it was actually in centimeters. That's annoying. You're like, why would you do that? And I don't think I would. If I was going to make a question like this, I go 12 centimeters, 16 centimeters, and I call that C. If it was my choice, I'll just call it C. Yeah? All right. Okay there? Any questions? I don't mean to rush it, but it seems like a lot of people are like, oh yeah, I kind of remember this. I kind of like the steps here.
I have the answer for D when we get there.
Katie's going to do D. She's going to come up and write on the board. She's going to take the microphone. She's going to speak to the class. Future teacher right here. Yeah, let's Joseph talk about C, okay? Because C's dangerous. It's the only danger in this whole thing. C. I like what he's saying. He's looking at it going, I can't use the Pythagorean theorem the normal way because h has got to be smaller. 13's got to be the big side. So he's jumping right ahead. So here, watch both ways and watch the two different ways you could do it, okay? He says,
A squared
did you say A or H?
A.
Okay, he's doing something clever here. And I don't mind if you do it. He says, hang on. I'm going to call that A right now because that works better for my understanding of the Pythagorean theorem. And he said, if you want A, which isn't the hypotenuse, you're going to have to go what?
C squared
C squared.
minus B squared.
So he's rearranged the formula in his brain and going, no, no. If we want A, we're going to have to subtract. So then what's C in this question?
C is 13 squared
Yep.
and B is 12 squared.
And the rest is the same, except for you're subtracting instead of adding. And so if you're right with me, you're like, oh, okay. So if I'm doing hypotenuse, I add. If I'm doing a different side, I got to subtract to get something smaller.
So I just, instead of A squared, I put B squared. Is that?
It totally works. A and B are sort of interchangeable. C is not interchangeable. C is the hypotenuse, okay? So I'm going to show another way, but hopefully most of you are convinced this is the way you want to do it. Most people choose the left-hand way. So 13 squared, you put in your calculator, 169, 144. A squared is 25. Crazy check mark thing for undoing squaring. A equals 5 centimeters. If you copied that down and you like it, keep it. But in festive green, because we're coming up to Christmas, I'll offer another way. Okay? Here's the other way. You just write down the formula. C squared equals A squared plus B squared. Then you go 13 squared equals A squared plus 12 squared, just like that. But just like in our equation solving, if I want to get A by itself, I got to move the 12 squared over, and that's why it becomes subtract. I'm not asking you to like that, but that fits together with what we were doing in other chapters, just doing the algebra. It really is the exact same thing. Here's the catch. If you're like, I don't get any of that, just make sure the hypotenuse is the largest side. It's got to be the largest side. If it's not the largest side, you've done it wrong. So you're like, I can't keep track of whether to add or subtract. Just make sure when you're done, the hypotenuse is the largest side.
Yeah, I did it the second way, still got the same.
Yeah, either way is good. And I'm not trying to say one way is better than the other. It's just how you understand it. And you might even change. I just ran into that in my grade 11 class today. During the lesson, a whole bunch of people changed over. At the start of class, we were all doing it one way. By the end, we were doing it a different way because we just decided that was the way to go. If this annoys you that I've got A on the left, on the right-hand side, because of the way you learned algebra, I'm here to tell you that's okay. You can do it there if you want, but you don't have to. You could have done this on the right side as well. Okay? Any questions there? There was a question.
I have a question. So, if like I was doing D and I did 24.
You're on D now already?
Yeah.
Okay, you're ahead?
No, this is for everything.
Okay, yep.
Would you like? I guess it's only for subtracting. Like, see, like you would have to put like the bigger number first. Right?
Yes, absolutely. Yeah, absolutely, because we're not going to be negative here. And you'll know when you type it in, you're like, whoops, other way around. Yeah, no, that's a good question. We don't always, you know, it's funny, my young son came home and said, the teacher said you always have to go bigger minus smaller. And that's true in a lot of situations. It's not always true. We can't have negatives. But there's not going to be negatives here. There shouldn't be any negatives here to deal with. All right, D. I'm just waiting for Katie to finish her message to her mom there.
I'm sorry. Anyways.
Was it your mom? At least tell me it was your mom, not some random who's supposed to be in their class.
Yeah, it was to my mom.
What number calculator do you have? Oh, I love this. Does this scare you?
Did you hear what she said?
Huh?
The answer for D is 34.6.
She says the answer for D is 34.6. Will you go through the steps with me so other people have it? What did you write? Tell me. Or do you want to come up and write?
No, thank
No, thank you, she says. Tell me what you wrote.
I did like the C, like this one and two, whatever the math equations.
Yeah, you like this formula.
Yeah.
Okay, good.
And then X, right, one and two.
Yeah.
Equals 24 plus 1 and 2 plus 25.
Okay, if somebody else did 25 squared plus 24 squared, would they get the same answer? Yeah, so it's okay. Those don't matter. So then when you squared 24, what did you get?
576.
And when you squared 25, what did you get?
625.
Okay. And when you added those together?
1,201.
Good.
And then when you like,
Put the check-a-doodle thing on it,
yeah.
called square root. What did you get? 30. Oh, it rounds to 34.7, does it? Well, tell me what the digits were before I round. 6 something? 6.5, which if you were going to do one decimal place, we'd call that 34.7 camels. Wagon wheels?
Centimeters.
Oh, sorry, yeah.
Meters. Please start writing the units. It's really important for those of you going on to trade type things. We really need to know. You're not going to walk in and go, I need 34.7. And they're like, 34.7 what? I'm like, I don't know. It was feet or centimeters or meters. I don't know. It's a really big difference. So we got to know which one we're talking about.
Mr. Todd,
Yeah.
can I confirm that?
And then when you're adding, you're doing
Listen, look at the whole back row. None of them with their phones out. We're improving dramatically. 10 is killing me, but all right, that's all right. Okay, I'm going to guess at her passcode here.
You're not gonna get it. I promise you. Look at where her fingers are, like, tilted towards the light. Wow.
No, I'm just kidding. Next person who has their phone out while I'm teaching, I'm going to type in the wrong passcode 8 times in a row. Do you know what happens?
You get locked out.
Locked out for an hour.
Not an hour, it's 5 minutes.
I know, if you wait 5 minutes and do it again, then it goes an hour. Sarah's like, I never have my phone out, so it's not a problem for me. That's not what you meant. You meant you never typed the wrong passcode? The only reason I know is because the pants I coach with hockey activate the phone. And so while I'm skating around, it's typing things and eventually locks while it's in my pocket. So. Found that out in a bad way. Okay, you have questions? One word problem. And then you can have some homework time. Aren't you excited?
Mr. Todd, I have a question.
Jackson, what's up?
In case of anybody who might not have done well on their test, could this be worth marks?
Ask me that question again at the end. Okay? Ask me that question again at the end. I'm willing to play. But last chapter, I made 2 riddle sheets worth marks. I got 7 people handed in the first one, 3 people handed in the second one. So I'll do anything, man. I'll do anything for you. I hope you know that. But if I make things worth marks and they don't hand in, then what?
It was a Napoleon.
It doesn't help me. Yeah, Chicken Napoleon and Definition Decoder. Yeah.
Yeah, I got that one.
Quiet, please. Quiet, please. Wall. Wall. What color should the ground be?
No. Blue.
Blue floor. You got blue floors at your house? Ground. And in festive green, ladder. Please, friends, if you're ever on a ladder like this, make sure someone stands at the bottom. and holds the bottom for you.
Where is this?
Isn't that the bottom of the first page?
Yeah, I found it.
Okay. A 4-meter ladder. So where does the 4 meters go, friends? The ladder. So you think I'm being silly drawing this diagram and carefully labeling it. I'm not actually being silly. I'm really trying to help you go. If you label these diagrams, it will help you. I know some people had some trouble with trees and shadows and so on. Actually draw them on there so you know where you're talking about. It says a 4-meter ladder is placed 1.5 meters from the base of the wall. So what's that? Is that up the wall or along the ground if it's 1.5 meters from the wall? On the ground. So this is the 1.5 meters. After that, you can take a deep breath because most people, all math people actually, take a deep breath once they got the diagram. My grade 12s are going through this right now. They're like, if I just had the diagram, I'd be okay. Once they have the diagram, I'm like, oh, it's going to be okay. The diagram's missing one thing. The wall, we're going to assume that most walls go up at a 90-degree angle. Does the wall have to go up at a 90-degree angle? Well, I guess not. I don't know if you've ever been in a house where the wall was leaning. But in grade 10 math class, all walls go straight up. Trees, towers, everything goes straight up. If it doesn't go straight up, can we still do the math? Yes, I'll show you tomorrow how to do it. But we're generally going to go wall straight up. Are we okay now? Who wants to take a shot at this then? Scout, tell me. She likes this. I like it too. It's the other version of the Pythagorean theorem. It's used for when you're not finding the hypotenuse. Okay, so go ahead. What did you do? Okay, just hang on one second then. If you're going to put A there, you've made the decision that this is going to be A. Totally allowed, but I think it's good to put it on your diagram when situations become more complicated. The rest is money. Am I saying that right? Is that what cool people would say? Oh, the rest is money. No? The rest is fire. Not saying it right? No. Alex like, nope, not even close. What'd you get next, Scout?
I got a squared equals 16 subtract 2.25.
Yes?
That's a squared is equal to 13.75.
Yes?
I did the square root.
And then you square rooted it? You didn't square root it yet?
3.7. Those odd numbers are.
Scout's doing it. What's the square root of 13.75?
The answer is 100.
Oh, it squared it. What's the square root of 13.75?
The answer is approximately 3.708.
Good. 3.7 wagon wheels? Meters. Write something there, please. Is it okay?